For this circuit, I want to find what is the value of R for which maximum power will be transferred to R. So again, as the previous problems, I have to find the from R's perspective, this resistance perspective, what is the line resistance, and there are two sources here. So I have to come up with, I have to replace the entire remaining part of the circuit with a supply and with a line resistance, and then the value of R has to be equal to the value of the line resistance. Only then R will get maximum power. So basically I have to find the Thevenin's resistance and Thevenin's voltage, which will as a result replace it to a supply voltage and a line resistance, which will be R Thevenin, and then here will be R. So we once we can find R Thevenin, we know that value of R will have to be the same, so that R gets maximum power. So in order to find R Thevenin, what we should do, we should remove R from the circuit. So we should make an open circuit and find the value of the open circuit voltage there. So this one is 20 ohms, 10 ohms, 8 volts and 12 volts there. So what's the value of this VOC? So of course there are two voltage sources, but this voltage, there won't be any current flow through this voltage source because there is an open circuit here. The only current flow will be in this loop. So the value of the current will be 8 divided by the total resistance. So I will be 20 plus 10 plus 20, 30. So that will be the value of the current. So the voltage drop across the 10 ohms resistance, the drop will be in this direction, of course, because of the polarity of the source. So that will be, so V10, if I say, that will be 8 over 30 times 10. So that will be 8 over 3 volts. So we can find what is the voltage here at this node. That will be 8 volts minus 8 minus 3 volts, because that will be the drop across the 10 ohms resistance, and here there is the rise of 8 volts. So basically that voltage will be 8 minus 8 over 3, which will be 16 over 3 volts. So that's the potential here. That's the very voltage of this point. So the voltage drop VOC, of course the voltage here at this point is 12 volts, because that's the only rise. Of course this one is ground. So this is 12 volts and this one is 16 over 3 volts. So we can find what is the value of the VOC. So that will be 12 minus VOC will be 12 minus 16 over 3 volts. So the voltage of this point minus the voltage of this point, that will be the drop there. So that will be 36, so 20 over 3 volts. So that's the open circuit voltage, which is V Thevenin's. Now we need to find what is R Thevenin. In order to do that, we have to make all the sources inactive. There are two sources. So once we make them inactive, the circuit becomes like that. So, and what is the resistance? 10 ohms here, 20 ohms here. So what is the resistance as seen from here? So we can see the resistance R Thevenin will be the parallel combination of 10 and 20. So 10 times 20 over 10 plus 20, that is 30. So that will be 20 over 3 ohms. Same value. So we have, now we know, since that's the Thevenin's resistance, we know the value of R has to be the same, so that maximum power is transferred to it. So we have our circuit. The entire circuit is replaced by Thevenin's voltage and Thevenin's resistance, which is R line, which is equivalent to line resistance for the load R, the resistance of our interest, that's R. So here VThevenin is 20 over 3 volts, that's the supply, and this one is 20 over 3 as well, but this is ohms, and this one is of course also 20 over 3 ohms. So we need to find what is the power dissipated by this resistance. So that will be, let's call it PR, will be of course I square R, that's the expression for power, and I here will be 20 divided 20 over 3 divided by the sum of the two resistances. So that's 20 over 3 plus 20 over 3 will be 40 over 3. This is the value of R times the resistance, which is 20 over 3. So of course 20 over 3 divided by 40 over 3 will be half. We can see that. So that will be the power PR will be half square times 20 over 3, or that will be 1/4 times 20 over 3, which will be 5 over 3 watts. So that will be the power delivered to that resistance. This is the maximum power possible to be delivered to resistance R.